PTL Pro represents the AI in Agriculture podcast where technology shapes the future of farming.
Hey everyone, and welcome back for another deep dive. Today, we're going to be looking at something that's pretty amazing. We're talking about artificial intelligence and how it's being used to tackle some of agriculture's biggest pests.
Yeah, it's incredible stuff. We're talking about these tiny insects that can cause massive damage to crops like the melon fly. These pests can really decimate harvests, and the traditional methods we've used to deal with them are often really slow and expensive, and they rely on heavy pesticide use.
Yeah, not exactly the best solution, right? But what if there was a way to detect these pests early and target them with pinpoint accuracy? Well, that's what we're going to be talking about today, because researchers have actually developed an AI model that can identify and count these tiny insects in real time. It could totally revolutionize pest control.
It's called YOLO MRC, and it's built on the latest object detection AI YOLO of 8. But the researchers didn't just stop there. They actually went a step further and supercharged this AI to make it even better at this specific task.
That's pretty cool. So how did they actually transform a general AI into a melon fly spotting machine?
Well, think of it like this. They gave the AI a magnifying glass and trained it to focus specifically on the pests. They essentially tuned out all the background noise in an image so it could really zero in on those melon flies.
Wow, so it's not just looking at the entire field, it's actually able to focus on the individual insects.
That's right. And get this, there's actually a visualization tool called a GradCam that allows researchers to see what the AI is looking at. It's like getting a glimpse inside the mind of the AI as it highlights the important parts of the image.
Oh, wow. That's fascinating. It's like the AI is actually thinking, gotcha, melon fly.
Oh.
But all this processing power must require a lot of computing muscle, right?
You'd think so, but the researchers found a really clever way around that. They developed something called the C2flite Module. And basically what it does is it streamlines the AI's code, making it incredibly efficient without sacrificing any accuracy.
So it's like they gave this AI the ability to do more with less. That seems perfect for something like a portable device that could be used out in the field. Farmers wouldn't have to carry around bulky equipment.
Exactly. And they didn't stop there. They also realized that this AI wasn't searching for huge objects like cars or airplanes. It was looking for tiny insects. So they simplified the part of the AI that's responsible for detecting those objects, which is called the detection head. And that saved even more processing power.
Wow. So we've got accuracy, we've got speed, and it all runs on a really lean system. That's incredible. But how does it actually perform in the real world?
Well, let's talk results. When they ran YOLO MRC through its paces on a data set of melon fly images, it achieved an amazing 99.3% accuracy.
99.3% accuracy. That's like getting an A+++ on a melon fly identification test.
It is. And the speed, well, they clocked it processing images in a blazing fast 5.6 milliseconds. To put that in perspective, that's actually faster than the blink of an eye.
That's crazy. Okay, so we have speed, we have accuracy, but what about size? Can this actually run on a device that a farmer could take out into the field?
Absolutely. The entire model is only 2.4 megabytes, which is tiny enough to fit on a small, affordable device like the Jetson Nano.
So we're talking about potentially putting the power of this incredible AI directly into the hands of farmers. That could really be a game changer. But before we get too carried away, are there any limitations that we should be aware of?
Of course. While YOLO MRC is a super powerful tool, it's important to remember that it was mainly trained on images of melon flies. So if it were to encounter other types of insects, there's a chance it could get a little bit confused.
Right. It's like asking a world-class chef to become a mechanic overnight. They're both skilled, but in different areas.
Exactly. And another challenge that the researchers are currently working on is how to deal with overlapping insects in images. That can throw off the AI's counting abilities.
Okay, so it's not a perfect solution, but it's definitely a huge step forward. It really sounds like YOLO MRC has the potential to totally change how we approach pest control.
Absolutely. And to truly understand how it became so effective, we need to delve a little bit deeper into how the researchers actually built and trained this AI.
All right, let's unpack the science behind this melon fly busting machine.
So, to create this melon fly detecting AI, the researchers really had to teach it what to look for, and that meant gathering a ton of data. And they came up with a pretty ingenious way to do that.
Okay, I'm intrigued. How do you actually create a training ground for an AI that's supposed to be hunting down tiny insects?
Well, they designed these special traps, almost like little insect hotels, And they baited them with this really powerful attractant called COUR. It's basically irresistible to melon flies. And then they set up these high-definition cameras to record the traps, capturing the melon flies as they were coming and going.
So they essentially created a melon fly reality show with the AI as the audience.
Pretty much.
Yeah.
And just like reality TV needs a ton of footage, they needed a lot of images for this AI to actually learn from. So they extracted a snapshot from those videos every 5 seconds, which created a massive data set of over 2,000 images.
Wow, 2,000 melon fly mugshots. But I've heard that AI training can require huge amounts of data. Did 2,000 images really cut it?
Well, they did something really clever to stretch that data set even further. It's called mosaic data augmentation. So imagine taking 4 of those melon fly pictures, rotating them, flipping them, adjusting the colors, and then stitching them all together to create a whole new composite image.
Well, that's interesting. It's like those photo collages people make, but with a scientific purpose. I bet that really helped the AI learn to recognize melon flies in all kinds of different scenarios.
Exactly. By using this technique, they were able to massively expand the diversity of their data set, which made the AI model much more robust and adaptable. It's like ensuring that a student is studying from a wide range of examples instead of just memorizing a single textbook. That way they can handle new challenges and apply their knowledge to different situations.
That makes a lot of sense. So now that they had this amazing data set, it was time to start building the AI. What actually makes YOLO MRCs so special?
All right, so remember how we talked about the AI's magnifying glass? Well, that's actually the first key innovation, the Multicat Module. What it does is it allows the AI to really focus in on the pests by incorporating an attention mechanism. Essentially, it learns to assign different levels of importance to different parts of the image, giving more weight to those areas where those melon flies are hiding.
So it's not just scanning the entire picture, it's really zeroing in on the important parts.
Exactly. Now, the second innovation, the C2flite Module, is all about efficiency. Remember how we were talking about streamlining the code to make it run faster and smoother? Well, that's exactly what this module does. It helps the AI to extract the most important information from the images, but while using less computing power.
It's like giving the AI a speed boost without sacrificing any of its detective skills.
Precisely. And then finally, we have the reduced detection head. And since we're dealing with tiny insects here, not jumbo jets, the researchers realized that they didn't need a complex system that was designed to detect large objects. So they simplified that part of the model, making it even more efficient. It's like using a small fishing net to catch minnows instead of a massive trawling net.
So they basically tailored the AI's toolkit to the specific job at hand. They turned it into a lean, mean melon fly detecting machine. But how do we actually know that this AI is as good as they say it is?
Right. Well, they didn't just take its word for it. They actually put YOLO-MRC head-to-head with 4 other state-of-the-art object detection models. It was like an AI Olympics, with each model vying for the gold in speed, accuracy, and efficiency.
Okay, so who came out on top?
Well, YOLO-MRC pretty much crushed the competition. It outperformed them in almost every category. It even proved to be much better at handling those tricky overlapping insects, which was a big stumbling block for other models.
Wow. So it's official, YOLO MRC reigns supreme in the world of melon fly detection. But this isn't just about bragging rights. This has real-world implications, right?
Absolutely. And now that we've covered the how, it's time to move on to the why. What does this technology actually mean for farmers, for the environment, for the future of pest control? That's where things get really interesting.
Okay. Let's dive into the potential of this game-changing AI. What could it really mean for the people on the front lines of agriculture?
Okay, so we've talked about how YOLO-MRC is this crazy fast and accurate AI that can spot these tiny melon flies. But how does that actually translate into something that can help farmers out in the field?
We can imagine a farmer using a drone equipped with this AI to scan their entire crop. It would be like having the super-powered insect detective constantly on the lookout for those pesky melon flies. And the drone could pinpoint exactly where the infestations are, creating a detailed map for the farmer.
So instead of just spraying pesticides everywhere, they could really target the affected areas. That sounds like it would be a huge benefit for the environment. Absolutely. Using less pesticide means less harm to beneficial insects, less contamination of water sources, ultimately a healthier ecosystem. And it also means lower costs for farmers who are often spending a lot of money on those broad-spectrum pesticides.
So it's a win-win for everyone. More effective pest control, less environmental impact, lower costs for farmers. This could really be the future of sustainable agriculture. But beyond those immediate benefits, what are the long-term implications of this kind of technology?
What's really exciting is the potential to move towards a more proactive approach to pest management. Instead of waiting for an infestation to take hold, farmers could use this AI to get early warnings, which would allow them to nip those problems in the bud before they spread.
It's like having a crystal ball that predicts where those melon flies will strike next. It could completely change how we think about protecting our crops.
Exactly. And because this AI can run on these affordable portable devices, it could empower farmers all over the world, even in regions that have limited resources.
This technology could really level the playing field, giving everyone access to those cutting-edge pest control tools. It feels like we're on the verge of a major revolution in agriculture.
It's definitely a game changer. And while the focus here has been on melon flies, it's important to remember that object detection AI can be trained to identify all sorts of things. You could use a similar approach to detect disease in plants, monitor soil health, or even pinpoint the optimal time for harvesting.
The possibilities are really endless. If we can teach AI to spot these tiny insects with such incredible accuracy, who knows what other challenges we can solve?
It really speaks to human ingenuity and the power of technology to address real-world problems. And I think that's really at the heart of what we do here at the Deep Dive. We explore these frontiers of knowledge, uncover these fascinating innovations, and hopefully inspire our listeners to think about the world in new and exciting ways.
Well said. And for our listeners, if you've ever wondered how AI is shaping the future, look no further than your dinner plate. The food that we eat, the way that we grow it, and the challenges that we face in protecting it. All of these things are being transformed by the incredible power of artificial intelligence. And who knows, maybe one day you'll even be using a similar AI-powered tool in your own garden, outsmarting those pesky insects and ensuring a bountiful harvest. Until next time, keep exploring, keep learning, and keep diving deep into this fascinating world around us.